This week on Let's Make It, we talk 7-segment displays, from going from one 7-segment display to 8. Show you some tricks with some special chips that make it real easy to do, and a whole bunch more stuff this week too. Lots of big news. So all that's coming up right after this. Let's Make It is brought to you by Ting, the new way everyone is getting their cell service. No overage penalties, great rates, keep what you do not use, no contracts, and someone will actually pick up the phone when you need support. Use our link and get $25 off your first month's service or your new phone. Just go to tech-zen.tv/ting to save $25. Hello, welcome to episode 22 of Let's Make It. And this week, Bob is back with me. Say hi, Bob.
Good evening.
I think your video and your Skype's a little bit messed up, but we'll deal with that one a little bit. All right.
Okay.
Well, it'll fix itself in time. It's just Skype being Skype. All right. So we have a couple things this week, but before we get into our main stuff, I have a couple news items that I want to go through. This one's one you're going to hear for the next 6 weeks until this is final. We are moving our YouTube channel to, we're basically combining all of our YouTube channels into one channel, and it's youtube.com/techzentv. So at this point, you've been probably watching us on youtube.com/TZ Let's Make It, and we're moving it all into one. And there's a couple of things, reasons we're doing this. First of all, last week, YouTube Live was announced, and we started talking about it through the week, trying to figure out how we were going to use YouTube Live, and it didn't really make sense with how we were doing our channel. So after discussing it with a few other broadcasters, it was recommended that we bring it into one channel. So for the next 6 weeks, Let's Make It's going to be published on both the current YouTube channel and the new one. But starting on episode 17, it'll only be on the new one. So if you're watching this on YouTube, you need to go, while you're thinking about it, to youtube.com/techzentv and click the subscribe button so that you don't lose any of our shows. So Let's Make It show is not going anywhere, then we're just moving where we are on YouTube. And there is going to be a playlist there just for Let's Make It, so you can still watch just Let's Make It without all these other shows being in the middle. This also allows us to do some cross promotion. Like I said, we're going to remind you of this twice on every show for the next 6 weeks. So go subscribe now, youtube.com/techzentv. All right. The next news item is something that's not necessarily related to this show, but yet it kind of is. And this is, I'm sure you've heard the term patent troll. And there's a company called Personal Audio LLC who is suing podcasters. They claim they're only suing large companies like NBC, ABC, things like that. But I do know of at least one or two podcasters, one of them being Adam Carolla, who they have sued for usage of the podcast or the RSS technology. They basically, sometime in the 80s or early 90s, something like that, got a patent on episodic release of content. So basically, that's what a podcast is. We release something every week, episodically, and they claim to have a patent on that. So what's happening right now is the Electronic Frontier Foundation is trying to put together a fund to get the money together to go after them legally and have that patent invalidated. And if you are interested in helping to protect the podcasting or the netcasting, whatever you want to call it, you can go to EFF.org, and I'll put the link in the show notes as well, where you can go and donate some money to that legal fund. I've donated to it because it could directly affect me ultimately. So far, they've never contacted me. I'm a small fish in the sea, so who knows? It could happen. You never know. Just as a side note, by their own admission, Personal Audio tried and failed at its attempt to make an audio player, and having failed at actually making it, it became a shell company that does nothing but sue for its patents. And the sad thing is, most podcasters don't make money, or not very much money. So it's just hurting ultimately the end consumer. Okay, a couple other things. Let me show you these. So these are shields from a couple of our previous shows on shift registers, and where you're going to start selling these in a store. We're going to start setting up a little store for things we do on Let's Make It. And Bob and I have been talking about doing shields for the shows, so that when we talk about a show, if you don't feel like putting together a breadboard, you can just buy one of these boards and the parts, and you can make it and learn how to write the programs and everything without having to use a breadboard. So that's something to look forward to coming up as well. We're probably going to put other things in there too, t-shirts, things like that, in the store as well as we start going forward. So now we do have an update on a previous show. We've been Bob been, I guess it was on YouTube, right? The comment was on YouTube.
Yeah, I saw the comment on YouTube a couple days ago. There's someone pointed out that I actually read the spec on the relay board episode a couple weeks ago incorrectly. I said 450 milliamps is what the relay was drawing, and it was actually 450 milliwatts of power, which when you work out the math actually works out that it is over the spec for what an Arduino pin is supposed to be able to supply. In doing some testing and double checking, because I was embarrassed and that I made the mistake and mad at myself for doing it, that I didn't read the data sheet a little more carefully, I did find that the relay actually does not pull that much current. It is slightly over what the Arduino pin is spec'd at. Um, so, I was wrong and he was right and he caught it. And, I'm sorry we had the wrong information out on that episode.
And we will update the show notes to have that change in there as well.
That's right. A better way of doing it would have been to put in a transistor. I probably would have used a generic NPN, probably a 2222 NPN transistor, which typically will supply something with 7 to 8, maybe 900 milliamps of current, depending on the manufacturer. But I probably would have gone with something like that.
Okay. All right.
But it's embarrassing, and I'm sorry.
It happens. Don't worry about it. I just appreciate somebody, bringing it up so we didn't leave it out there like that.
Yes, that's right. And it's good that it's good that somebody said something, and the show comments. I mean, it is something that that I'm watching, and I know you're watching. So people have questions, comments. We're going to answer.
Right. Okay, so this week we're going to go through 7 segment displays, and Bob has all this pretty much this week. I actually have one here, and before we go too far, I want to explain what not to do. I had this
Yeah,
I had this working, and you see the chip up here and the 3 segments. So I got this package from Mauser that had really cool 7 segment displays in it, and I stuck it in place of these, and they were the wrong type. They were common cathode, not common anode. Is that right, Bob? I got it backward again.
Other way around.
They were common anode instead of common cathode.
This chip wants a common cathode.
Right.
And
so
you put in common anode. Right.
When I put those in, they pretty much stayed on all the time, didn't do anything. And by the time I put these back in, these now do the same thing. So I probably burnt that chip out by putting them in backwards. So we probably want to explain a little bit the difference between common cathode and common anode. Common cathode and common anode are basically on these 7 segment displays. There are 7 pins and plus 1. Basically, the other one is the common. It's either anode or cathode. And then the other 7 pins are the opposite end of that LED. So if you look at an LED, there's an anode and a cathode on every LED. And these 7 segment displays actually share 1 pin between them for either anode or cathode. So you got to be very careful when you buy them, which one you're buying and what the chip needs. So my mistake, I didn't get the right ones and put them in. It was backwards and blew out a chip. So, all right. So Bob has on his side a 7 segment display. He's going to show.
All right. Yeah. Let me switch to that camera. So here it's in the middle of a sequence right now. And actually, the sequence is starting back right now. That's the beginning of it. And this is actually we're reusing the same code that we've used several times before. That's a 595 shift register, the same generic code that we've used on a couple episodes now. It's just modified slightly to do something with a 7 segment display. And then I've put in all the letters that you can have. Uh, it's got a full alphabet in it, but of course they don't. Some of the letters don't look quite right. Um, and then of course that display just said Bob was here, and then we've got a little figure 8 display and a little round and round we go. And I don't know what to call that. I just think it's cool. So that's me playing. So, but this is this is an example of you write generic code and then just reuse it for your application. And here we are reusing the same code and the same chip and just having a different display right there.
All right, so you want to hop over to the code real quick?
Sure.
All right. So you're going to see very similar stuff at the top as we had before, right?
Yeah, this is all the same. Since this is generic code, it's called, you've got the variable number LED and number of registers, and of course we just have one, and we use 8 because, we call this a 7 segment display, but there is actually an 8th digit, the decimal point. So you do have 8 inputs into that display. And then the rest of it is set up just like we've done in the other examples that we've had in the past. So same comments. Um, the only difference between this code and the previous code is I do have some explanation about hooking up the 7 segment display, and there's a new function specific for the 7 segment. And then a lot of the extra code that we wouldn't use, I've stripped out. But right there's a link to to how the displays were organized and how what segment is called what. So, and this is a common cathode display that we're using.
Right, which means all the other pins are anodes.
That's all right. All of them are anodes, which makes it really easy to power from a shift register.
Okay, so down here you're laying out how these 7 segments lay out, right?
Yeah, and this is just kind of try to explain how a 7 segment, the top character, is segment A, and then it goes clockwise around the display. B, C, D on the bottom, E and F on the left, and G is the bar in the middle, and then the decimal point. And then we get to a section a little further below where, this is a long-winded way of doing this. There are more efficient ways setting up hex code rather than showing. But in this example, I wanted to show how you put the pieces together to make a letter A. How do you make a letter B? So that's why all of this rather long-winded code is in there, is to help explain how someone can put the pieces together to make the display they want.
Right, and if somebody's not familiar with binary, this is basically the same thing as doing a binary. So the first byte or bit is 1, second bit is 2, third bit is 4, fourth bit is 8, fifth bit 16. So you got the line like that. That's basically each individual bit into the value. And if you add them all together, it's like you're combining a hex value or something to it as well.
That's right.
So
so you get all the numbers, you get all the letters.
Okay, so yeah, you're creating an array with segment A, B, C, D, E, F, G, and H. And then you're defining the numbers, and you're basically turning on different segments based on this. So this one is everything but A, B, C,
the G.
The G, yep, the center one. So
right,
the center one's missing. So you can see, and then here's the segment B and C, which are the two right sides. So you basically can see how he's adding these together and getting the number right there. And then you're putting those into an array, right? Right there.
Yep. Yep.
And then
And then those arrays are really just convenient. You know, it makes it convenient to display numbers by setting up arrays like
right, you
that.
can just loop through it that way.
That's right.
And I remember we talked about this. You went to Wikipedia to figure out a 7-segment lettering scheme, which doesn't look the best, but it's the only way you can do it, right?
That's right. And the only place that I deviated from what you find in Wikipedia is on the letter S. Um, my S is the same as the number 5. Um, I just couldn't stand the way the S looked, so
Okay.
I changed it.
So 5 and S look the same, basically.
That's right.
All right, so you define each letter for n as a constant. And you put that in an array too for the same thing. You can loop through those really easily. Plus, you also added space and a period.
That's right. And the period is the decimal point that we mentioned earlier, and a space is really just convenient. You know, make it convenient to have a string running across the display.
Right. All right, so we're going through the setup. This is the same as the previous one, correct?
Exactly the same. Setup is exactly the same. The loop is um, all of the other functions that we don't use were taken out, and then I just have that that one that I've added.
The 7-segment tests right here.
That's right. That's it.
Okay.
And all the rest of the code is just like what we've used before.
All right, so let's go into 7-segment tests. So your first one, you're going from 0 to 10 and back to, and then 10 down to 0.
That's right.
So you see he's counting up right there. He's counting down right there. Turns it all off. And then you're doing A to Z.
Yep. Same thing. Just going up the string, and then I have this little message that I scroll across the screen.
All right. See Bob space was space here period.
That's right. And that last one, you know, in binary math, all I've done is I've taken the E and then added the constant for the period, which is a decimal point, and then of course it displays the period right there with the letter.
All right. Very good. And then you do the figure 8 pattern.
And then I do the figure 8.
And you just do it 5 times around the loop. And
yeah, just a couple for loops to display.
And then around the world, forwards and backwards.
Forwards and backwards.
Okay. Oh, okay, that was the forward right there. We just looked at. So you do around it 5 times.
Yeah, I do each direction. And in between, I hold the last segment. I hold that last segment for just a moment, so it just so it looks good.
Okay, so we used one right here, 50 millisecond delay, and then you go backwards.
And then I go backwards.
And you clear it out, and you do this other.
I don't know what you call it. I just, I stumbled across that display. That visual. I just happened to like it. So, and I think it's about to come up in the pop-up again.
Oh, it is.
I see you've got me in the you've got me in the picture. There's round and round, and I don't know what you call that, but
okay.
Yeah, it just makes it's cute. It makes you laugh. So.
And then let's go back. I think we're almost done here, right?
That's
done. That's it. Okay.
That's it.
And all the other functions we've gone through before in the previous episode, so you can go back
That's
and
right.
watch those for those. So we'll put this up in the show notes, the link to it in the show notes. And
the code is already posted on GitHub now.
Okay, good. So let's see. The next thing we have is a new chip, and it's for up to 8 7-segment displays. How many do you have on yours, Bob?
I've got 8 in the other display.
You do have 8? Okay.
Yep.
So yeah, it's a different chip. We're going to switch over. This is a chip that's a little more expensive than the ones we've been playing with. What was it? About $12 a piece, something like that.
10 and change, yeah.
10 and change. So, but the chip itself is much more powerful than what we've been doing. It supports up to 8 7-segment displays. Also allows you to dim, and these can also be chained together to do more than 8 if you want as well. Much like the shift registers have been in the past, works very similar. So
This is a real nice chip. It's the I don't think we mentioned it. This is the Maxim 7219, and it does the PWM and the multiplexing for you. So it is more expensive. It does, cost a little more, but it's doing a lot for you.
right,
So,
and there's a lot of wires there.
and there's a lot of wires there.
So
So,
I think something we probably want to explain is that um, there's more wires than there are pins on the chip here, and that's because the pins on the chip that run to the anodes basically go from digit to digit. So a pin runs to the first digit and then runs to the next digit. The same pin, the same anode pin, on all the digits, and because of that, the wiring is much simplified compared to running a pin for every anode. I mean, you still have to
right.
run a pin, but it's only one pin on the chip for that.
Yeah.
So,
So,
and then there's a cathode wire that also goes to the chip. And the way the segments work is it cycles down the line. So it's happening so fast you can't see it, but it's basically turning on the right anodes and the cathode for a digit, and then for a very short period of time, and then going to the next digit and turning on the right anode and the cathode. So basically, the one you just left is turned off, but it's just so fast your eye can't see it cycling down the line.
yeah, and I couldn't find in the data sheet what this was multiplexing at, but in reality, anything over, well, I know when you're doing, like an LED cube or something, if you can multiplex at 500 hertz, just 500 hertz, the human eye can't see it.
Right.
So,
So
and this is multiplexing much faster than that.
right. So if we did not multiplex, it would be what 64 wires. Well, it'd be more than that.
64 wires,
Well, it's 64 anodes and
8 cathodes.
8 cathodes that would have to go to that chip. So that's total of 72 pins, and you see we're actually doing it with 16 because of the multiplexing. And it doesn't look that
That's right.
simple, but it really is much simpler than if you had to run all those chips to all those wires to that one chip.
Yeah, it's kind of the wiring looks kind of scary, but it really isn't. All the anodes are connected, and that's the mass of wiring that you see on the bottom and the top.
Right. So they're just
And
going digit to digit, basically. They go into one digit, comes right back out, go to the next digit, right down the line.
that's right. And then each cathode is connected to the 8 cathodes are connected to the chip.
Right. So the other thing the chip is doing is the pulse width modulation, which is how bright the LEDs are. And so in addition to turning off and cycling through all these LEDs really fast, it's also, while they're on, cycling them off and on to get the brightness level up or down. So you're running what, 30% duty cycle? Was that what you said before?
I'm doing I've got it set at 3 of 16, so 20%,
Yeah,
22%.
right.
And I had to turn it down so it would look okay on the camera.
Right. So basically what that's saying is 78% of the time the LEDs are off when they're supposed to be on.
That's right.
So all this is happening at this one little chip is doing all this work for you. The other thing that it gives us is one resistor for all of the LEDs. If we did not have it like this and we were running 64 wires to every anode, we would also have to run a resistor to every one of those as well, because there's not a common way to save that, so, or just to reduce the power. So with this chip, it's one resistor. Well, I think you're using a couple in series, right?
Yeah, I actually have 4 10K resistors in series, which effectively makes it's the same as a 140K resistor.
Right.
So I'm using one resistor rather than 64. I'm using one chip with 16 connections rather than 64 plus 8.
So yeah, so this makes it much simpler. It doesn't look simple, but it's much simpler than if you had to do it individually. The other cool thing about this chip is if you can put them in series. So if you want 16 digits, you put another chip behind it, and pretty much wired up the same way. Kind of like you remember shift registers, there was a data out. It's the same thing on here. It goes to the next chip in the series and allows you to do 16 digits.
Yes, that's right. And we don't have the demo. We're not showing it here, but this chip also does. It can also be used for an LED cube, and it can also be used for matrix displays, LED matrices. And there's a library that the library in the code is from the Arduino playground, and it actually supports all three of those situations.
Right. I guess we did not mention that the code you're using actually is from the Arduino playground for this chip.
Yeah, the basic library is from the Arduino playground. It's freely available, and we've got the link in the show notes.
Right. And we're actually going to walk through his code too. You can see how this is working. The library makes it much simpler. When I was first starting to play with it, I was actually doing it without the library, sending the codes down to the chip, and then the library makes it so much easier to use.
Oh yeah, the library is really easy to get things moving very quickly. So
All right. Would you want to hop over to the code and take a walk through it?
yeah, let's switch to the code.
Okay. All right. This is the 7-segment demo code. Let's go down here a little bit. So you want to explain this?
Okay, what this mess is right here. There is one change that I made in the library. When someone downloads the libraries, there's going to be a .h file and a .c file, and those files get included and compiled in when the Arduino IDE compiles the code. Because I wanted letters, I changed my .h file. And this section right here is where all of the ASCII characters are being defined. So in much of this, the letters were left out. They just did not define the letter because let's face it, most letters don't look good on 7-segment displays. So I fixed all the letters. And the other thing that really kind of surprised me is the very first ASCII character 1, which is in that array, would be position 0, the very first one. In the original library, they had it set up so it would make a 0 for a null. And when I was first getting this working, that drove me nuts because I couldn't figure out why I was having empty characters that were showing up as zeros on the display. Well, that's because this table set it that way. So the two changes is that I added all the letters and then changed a null to be nothing. The other the other zeros that you see in here are for the other ASCII characters that we don't.
The non-printable characters.
Yeah, a carriage return, a tab. I mean, obviously, we're not going to use those on a display like this. So all of those in the library, you still have to define them to make so the rest of the software understands what you're doing. But they are defined as zeros, so that's why there's so many of them in there.
All right. So we get down here. These are the letters right here.
Those are those are the letters in there. And uppercase and lowercase are all defined exactly the same. We don't differentiate here.
Okay. All right, so this is the library you need to include, LED control.h. That's the one you modified, right?
That's the one I modified. And there's a link to the playground where on the Arduino playground where I got it.
Okay. And let's see, there's your pin setups.
Yep. And that command right there is compliments of the library. All you have to do is tell it, your latch pin, clock pin, data pin, and how many of the 7219s you have connected. So in our case, I only have one, and there and our 3 pins.
All right. And
So it's
then
really easy.
number of
And
7
then
segment displays.
and then here's just a couple constants for the code later on.
Okay.
And the space, I probably should take that out, but I left it in because I recycled a little code from the other demo, and I had space in there.
Okay.
But I could probably take that out.
All right. Oops. Went zoom in fast. All right. So here we do setup.
And the setup is pretty straightforward. You wake the chip up, you set the intensity, and that's where I'm setting the 3 out of the 6. You can go from 0 to 16
Okay.
in that intensity, and that's where you're setting the PWM setting. So a duty cycle 3 out of 16, 22% roughly. 20%, whatever that works out to be.
One of the things I think we should probably mention here is the shutdown, even though it says shutdown, is actually doing the opposite. It's shut down with a 1 shuts it down, right? Or shut down with a true.
Shut down true means that you're shutting it down.
Right.
Shut down false means that you're turning it back on.
Right. So it's kind of counterintuitive. Shutdown shouldn't be the word
right.
shutdown. It's confusing. All right. So you do the clear display.
And then we set the intensity, and then we're off into the code.
All right. So you have a lot of other functions we're going to get into here. This is the actual loop, though.
Yeah, that's the loop, the Arduino loop function, right?
So here you're you're scrolling text across, and demo.
Right.
Let's make it. And we'll go through scroll text a little bit here. Do some counting. So you're counting from where? To 0 to 250?
Yep. And then 250 back to 0.
What's the 10 for?
That is
the wait time, or?
You would ask me something I don't remember offhand.
That's okay. We'll keep going. We'll get to that soon anyway. So
okay.
All right. So we're doing the counter again, and then we're doing display text.
Yeah, and the display text is just puts it on the screen, and then that those next functions where I have right, left, and center. I wrote a function that just justifies the text either to the right of the display or to the left of the display, or just centers whatever you have. And of course, you have to have, the text has to be smaller than what your
right,
the number of display, digits you have.
Okay. And then you're going to scroll text. A.
I'm just scrolling the letter A across the displays.
Okay. And then the word scroll. And then A through H.
Right. And this, and the reason I have all those in there is because it makes a difference. Later on in that scroll text function, if there's fewer characters, it's all for states. Are there fewer characters than half of the display? Are there more characters than can be displayed? Is there exactly the same number as how many digits you have? So I put all that in there just to test and make sure that everything's scrolled correctly.
All right. And that's the end of loop. So now we'll get down to the functions. So here's your counter function. Yeah, your duration was the third value. So all you're doing here is looping from the start number to the end number.
That's right.
And waiting for the duration for each loop. And should we explain I to A?
Yeah, that is it's a integer to ASCII. Sorry. and it's just and that's where that table is actually coming into play. It's just because you're sending a character, um, binary to the display.
Right. Okay. Yeah, and we should probably mention that that's not some of the standard C functions are not in the Arduino language. Even though it's based on C, there's a lot of things that are missing.
Yeah, that one works correctly. Uh, there's another place where I wrote my own little function, um, rather than using the Arduino size of command. Um, because I needed to know the number of characters in a display, or I'm sorry, and the number of characters in the string.
Right. So display text then puts the text on the screen, right?
That's right.
Okay.
And the two functions that are here that are really that are important is the copy array, and this is actually something real important to bring up, because when we read things, we read left to right, and the strings that we put in, the position 0 would be the left, what we would think of as the left hand character. But between this chip and this library, position 0 is actually the right hand character. So that copy array is basically translating left to right reading characters into right to left reading characters, and then the next that little uh, if you scroll down, where is it? Oh, you get. I'm sorry, I looked away and you got away from me.
I was still in the count. The
Oh, you were
count.
still in count, and
Yeah. You were down in display text, right?
I was in display text. I'm
Yeah.
sorry.
I'm getting there now.
So there's the copy array. That's doing the translation, and you're telling it where to start the first array, where to start the second array, and how many characters to translate. And then it's just a simple little for loop that sends the characters to the chip for display.
Okay, so this is like the workhorse, right? Basically, everything uses display text to put to the screen.
Pretty much.
Okay, and then you're sending in the string that you want to put out, and yeah, so you copy your array, you put it in backwards, basically, then you start sending it out.
That's right. And then just and as quick as you can get it out is you see there's no delay right there.
Right.
And it's running as fast as the Arduino will go.
All right. And then we come down to display text just, which is your justification routine.
That's right. And it's basically the same as before, only now we're paying attention to, do we want to justify things on the left side of the display? Do we want to center them? By default, it's justifying things on the right.
Okay. And you just got the same copy array, just now you're doing it at a different location.
Right, that's right.
And then we set the characters in the library.
Use the library to set the characters.
Okay, then we're coming down to scroll text.
And this one was, this actually took me a while to figure out how to get things to scroll across the screen correctly. But basically the code is that we figure out where the starting position of the display is going to be, the starting position of starting position of the array of the string that we got into the function that we're displaying, the starting position of where do you start in the display, and then how many of the characters do you characters do you put onto the display at any one time? And those variables right there are all, I'm using all of them to figure all that out.
Okay.
So even I wrote this and I'm still confused to how I got it to work. So Yeah, I mean, sometimes, this is one of those that, people who program for a long time, they know sometimes you just bang your head on the keyboard until you get it right. And this was one of those little pieces of code that I just banged on it until I got it right. Um, but I tried to write it where, I used formulas and variables, and then um, made sure that they were within the correct limits.
Right. Yeah, I kind of see what you're doing, just determining how long it is, if it's going to be past the end or not. So yeah, I mean, you're doing some checks here.
Yeah,
So
I'm doing a few checks.
yeah,
Well, some of them I have to. You
right,
can't, if the string you're displaying is 10 characters, but you only have 8 digits, well, obviously you can't display all 10 at one time. So you can never have more than the number of digits.
right. So after you figure out the starting and everything, number to copy, you basically do copy array again and put it back out.
That's right. And all of those are going up and down. As you're scrolling across the displays, all those variables are changing as things go across.
Right.
And then at the end, we do the same thing. We translate our display and send it to the chip.
All right. And then copy array. So you're clearing it first to make sure it's empty. That's good.
That's right.
And you are at each loop, your destination starts going backwards and source starts going forward. So you're basically reversing everything.
That's right.
That's easy enough. And then here's the array length. And this was something that the function didn't work as it does in C. So you had to rewrite this, right?
Yeah, the correct function should be size of. And in Arduino's implementation of C, it doesn't work correctly.
Right.
It does not consistently give the values that I was expecting. So I just wrote this very simple little function that just counts the number of characters in the array, and then returns that number.
All right. And then the last function is clear array. Just clears everything out. That's easy enough, right?
Just clears everything out. And this is where, I'm using that variable space, and I could just as easily use a binary 0 right there.
Right. All right. All right, so this will be up in the show notes as well, and I'll link to it on GitHub.
Yep, it's already up there. It's already posted.
All right, great. Okay, so let me go back and look at the show notes. I think that's all we had for the night, isn't it?
I think that's it. Yeah.
All right, so
this was a nice chip. I liked it.
Right, yeah, it is nice, and it's the fact that it does all that stuff for you. It's a little salty price wise, but if you consider what all you have to do it without the chip, the cost probably isn't that much more really, and plus the pain is much less.
It was pretty painless putting this display together. So
yeah, much better than having to do it, using some other kind of multiplexing, which we are going to talk about multiplexing in a future show. We've had the questions about that.
yes.
Not sure what show we're going to do it in, but we are gonna look at that. I guess somebody called it Charlie plexing, which is basically multiplexing.
It's slightly
a variation
different.
of it. Yeah, slight variation of it.
It's a variation of it, and it was created at a time when microcontrollers weren't powerful. You didn't have the horsepower that we have today, but you had to design and build what you were doing in a very specific way. And I've never actually used Charlie plexing, because by the time multiplexing is just too easy now to go use Charlie plexing.
Right.
But if somebody was interested, there's a fairly good article on Wikipedia.
Good old Wikipedia.
Go to Wikipedia. Charlie plexing is there. It is interesting. It's just rather outdated, and it becomes very complicated as you scale your project up. So complicated to the point that a microcontroller is just way too easy.
Gotcha. All right. Well, we want to remind you again that we are moving to a single YouTube channel. It's youtube.com/TechZenTV. Go there now and hit subscribe. If you've been getting us through podcast downloads, make sure you are subscribed. You get our updates automatically. The podcast is not moving. That will stay right where it's at. We're only moving the YouTube channel. Nothing else is changing other than that. But if you are on getting us through like iTunes, something like that, go out and give us a 5-star rating. That's appreciated. A little comment out there helps us. It helps us a lot with our iTunes, getting found in iTunes. The more people that go out there and give us ratings, the more likely we are to be found with iTunes. And we do have to try to get our subscribers up on the new channel over 1,000 so we can go to YouTube Live. Our other channels are all fine. We're over 1,000, but now we're moving everybody into one channel. We have to ask everybody to resubscribe again to get us up over that 1,000 mark. So please, if you get a chance, you can do that. I don't know if I've ever mentioned this before, but we do have a Roku app that you can watch all our shows on now, even the new shows that are coming out as well. And if you want to send us a video of something you've made or have questions, just record a video, use your cell phone or whatever, and upload it to YouTube or Vimeo. Send us a link to it. Or you can always send us an email to letsmakeit@tech-zen.tv. And we do answer you back. It might take a couple of days to get back to you, but we do answer you back. You heard us tonight talk about some feedback we got from one of the viewers about something we misstated on a previous show, and that's came through feedback, and we love that kind of feedback. It's great to get that kind of feedback. So I think we've pretty much covered everything this week, right?
I think so.
All right. So Bob, thank you very much for being on the show. We'll see you again next week, right?
Thank you. Yep.
All right.
Right.
All right. See you, everybody.
Good night.
For show notes for this show, contacts, and more, go to the techzen.tv website where you can get show notes for all of our shows. We love to hear from our viewers and listeners. We have an email, a Twitter, and a phone number where you can contact us for each show. For details, visit the techzen.tv website and get the show details. You can also make a video and upload it somewhere like YouTube or Vimeo, and then just send us a link. You never know, you may see your video in a future show. You can get all of our shows delivered automatically to your favorite device by going to your favorite podcast website like iTunes and subscribing. Each of our shows also has a YouTube channel you can subscribe to get regular updates. Our shows are also available on most internet radio networks like Stitcher and TuneIn Radio. You can also watch and listen to our shows on Xbox, TiVo, and Roku. You can even find us on your Zune.